Assalamu alaikum, dear students. Today we are going to do question number 4 of exercise 7.2, in which given is that ABCD is a trapezium. ABCD is a trapezium in which AB is parallel to DC. This AB line is parallel to DC line. BD is a diagonal and BD is a diagonal. E is the midpoint of AB. E is midpoint on AD, and EF is parallel to AB, and this EF line is parallel to AB. This is given, so we have to prove F is the midpoint of BC, that F is the midpoint of BC. It is given that E is the midpoint of AD, and we have to prove that F is the midpoint of BC. So the proof is, let us take triangle DAB. This is triangle DAB. In this triangle, E is the midpoint of AD, which is given, and EF or EP is parallel to BC. This is also given. So P should be the midpoint on DB, because it is converse of midpoint theorem. You have read midpoint theorem, and that when the line segment joining the midpoints of two sides of a triangle is parallel to the third side and is equal to half of it. The converse theorem is that E is the midpoint on this side, and this line is parallel to third side, so P is the midpoint on DB. So in this triangle, E is the midpoint of AB, as I told you, and EP is parallel to AB, so P is the midpoint of DB. So this is converse of midpoint theorem. Now let us take triangle BCD. This is BCD. In this triangle, we have proved that P is the midpoint on DB, and it is also given that EF line or EP line, this is parallel to side AB, but AB is parallel to DC, so these two lines are parallel to each other, and this line and this line, they are parallel to each other. So we can say that FP or EP or EF, PF or EP is the part of line EF, so we can say that PF is parallel to DC line, and P is the midpoint of line BD. So as per converse midpoint theorem, P should be the midpoint on line BC. So in triangle BCD, P is the midpoint of side DB. Here P is the midpoint on this side, it is proved, and it is proved above. And FP is parallel to DC. FP is parallel to DC line, because AB is parallel to DC, it is given, and AB is parallel to EP or another part of this line EF or another part of this line FP. So AB is parallel to DC, and AB is parallel again parallel to FP. So DC is parallel to PF. So we write here DC is parallel to PF. So P is the midpoint of side DB. When P is the midpoint of side DB and PF, which is the line joining from the midpoint of one side and is parallel to the third side, so P should be also the midpoint, so that PF is parallel to DC. So therefore F is the midpoint on BC. It is also the converse of midpoint theorem. So we proved this point also. Thank you.